Good stuff going
General
on.
relativity.
All right, so I'm gonna explain some general relativity. All right, so back in the early 1900s, Albert Einstein was thinking, you're in a train station and you see a train passing by. Think of two people, they have a ping pong and the ping pong falls down.
Okay.
What they see is the ping pong falling straight down, right?
Yeah.
And they time it for this amount of time. An observer outside the train that's stationary, they see this ping pong, but since the train is moving, they see the ping pong like that.
Yeah.
And because of that, that's like it's traveling a greater distance to them, so they calculate it as a greater time. That's how you came up with the thought of general relativity.
It's not just traveling down, it's traveling that whole hypotenuse of the triangle.
Exactly.
Right?
So if you think of the same way light beams, if it's traveling down, as it's moving, light travels that greater distance, okay?
Yeah.
So general relativity, it comes up with the theory of how time dilation occurs. So nothing can travel faster than the speed of light, right?
Yeah.
Even if you're traveling at 0.99 the speed of light, if you see light pass by, you're gonna measure it as the speed of light. How is this possible? Time dilation. So basically, there's an equation, and essentially you can think of two twins. They're on Earth. They're born at the same time, everything. They leave at the same time. They take off. One is going space shuttle speed, I don't know.
Sure.
It travels for 5 years back, 5 years back, 10 years total. Another one is traveling at 0.9 speed of light. They go 5 years back, 5 years back.
Uh-huh.
When they come back, hundreds of years will have passed due to time dilation. The faster you go, the more time dilates. So essentially, what these people are experiencing, they experience 1 second. A stationary observer, they could be experiencing 10 seconds, 20 seconds, 30 seconds because of time dilation.
So you're here on Earth and you experience more time than them, right? That goes back to what you were saying. So like if you have the train, if the ball just falls, for them that's what they're seeing. They're in that spaceship, they're going really fast, and they're seeing that amount of time pass. But from here, they're gone for way longer.
Exactly. So essentially, it's essentially time travel into the future. It's crazy to think that time dilation equation works for anything. Even if you're walking, you have a time dilation effect.
Yeah.
But granted, it's negligible.
Sure.
But satellites out in space, they have to account for this. So all the reason why we have such powerful GPS methods and all this is because of special relativity.
And we account for that.
We account for that. But essentially, satellites out in space are time traveling. And it's also not just because of how fast they're traveling, but also he found out that the greater the mass something has, it bends space and time, right? So if you're closer, you're experiencing a greater gravitational force, right?
Yeah.
So you're experiencing more time.
You have the fabric of space-time, and then here's Earth, and you put Earth on there, it's gonna bend that thing here. If you're on it, you're like experiencing the full gravity that is standing on this Earth.
Yeah.
But if you're a little outside of it, which is like you're a satellite orbiting, you're not at the well. You're a little above that.
Yeah. So you can think of like a black hole, and due to the same concept, if you're traveling around a black hole, you can use it as an essential time travel machine where you're traveling around this for let's say 5 years. If you were able to come out, 1,000 of years could have passed. It depends on how strong the gravitational force is.
Yeah, and that was getting into like using a black hole for